Hello everyone and welcome back to the channel. Before we dive into today's incredible success story, make sure to hit that subscribe button and turn on notifications so you never miss our deep dives into how the world's most powerful industries and empires were built. Now, let's get into the video. In 1999, a relatively small computer hardware company named NVIDIA introduced a brand new product called the GeForce 2560. They branded it as the world's first graphics processing unit, or GPU. For decades, teenagers and gamers knew NVIDIA as the ultimate engine behind their favorite video games, rendering realistic shadows, reflections, and high frame rate explosions. Fast forward to today, and NVIDIA is no longer just a gaming company. It is a multi-trillion-dollar titan sitting at the absolute center of the global artificial intelligence gold rush. In fact, companies like Microsoft, Google, Meta, and OpenAI are practically begging NVIDIA to sell them their latest chips, waiting in line for months and paying tens of thousands of dollars for a single graphics card. How did a company that started as a casual conversation in a highway diner transform into the most powerful gatekeeper of the future of human intelligence? It wasn't a sudden stroke of luck, and it wasn't because of a sudden trend. It was a 20-year trillion-dollar gamble that almost bankrupted the company, but ultimately allowed them to build an inescapable monopoly. This is the untold story of how NVIDIA took over the artificial intelligence industry. To truly understand NVIDIA's massive takeover, we first have to travel back to its origins in 1993. Three microchip engineers, Jensen Huang, Chris Malachowski, and Curtis Preem, met at a Denny's diner in California. They realized that the next wave of computing would be highly visual, and that traditional central processing units, or CPUs, were terrible at handling three-dimensional graphics. A CPU is like a highly educated professor. It can solve incredibly complex tasks, but it can only do them one at a time. A GPU, on the other hand, is like thousands of elementary school students solving basic math problems simultaneously. It handles massive, parallel workloads. While this architecture was perfect for rendering millions of pixels on a gaming screen at the same time, NVIDIA's co-founder Jensen Huang had a vision that went far beyond video games. He realized that if a chip could process millions of pixels simultaneously, it could also process other massive parallel mathematical problems, like physics simulations, oil exploration data, and eventually, neural networks. This realization led to NVIDIA's greatest and most painful gamble in 2006, the creation of CUDA. CUDA, which stands for Compute Unified Device Architecture, was a software platform that allowed developers to program NVIDIA's gaming chips to perform general-purpose mathematical calculations. Before CUDA, writing code for a GPU was incredibly difficult and required deep knowledge of graphics programming. CUDA made it accessible to scientists and researchers worldwide. However, this move was incredibly expensive. NVIDIA had to spend billions of dollars to build CUDA compatibility into every single chip they manufactured, even though almost nobody outside of a few academic labs was using it at the time. Wall Street hated this strategy. They accused NVIDIA of wasting billions of dollars of gaming profits on a niche software project that had no market. NVIDIA's stock price plummeted, and the company faced severe financial stress. But Jensen Huang refused to back down, believing that the future of computing lay in parallel processing. That stubbornness paid off spectacularly in 2012 during an artificial intelligence competition called ImageNet. A researcher named Alex Krizhevsky built a deep neural network called AlexNet to classify millions of images. Instead of using traditional CPUs, he trained his neural network using two consumer-grade NVIDIA GeForce graphics cards programmed with CUDA. The results shocked the scientific community. AlexNet obliterated the competition, proving that deep learning combined with NVIDIA's hardware was 10 times faster than anything else on Earth. Almost overnight, The entire academic and scientific community realized that NVIDIA had accidentally built the supercomputers required to make artificial intelligence actually work. Instead of scrambled pixels, those thousands of tiny processes were now calculating the connections of artificial brains. When the artificial intelligence boom officially exploded in the late 2010s and early 2020s, NVIDIA was already 2 decades ahead of its competitors. When OpenAI needed to train the massive language models behind ChatGPT, they didn't use CPUs. They used tens of thousands of NVIDIA A100 chips. When Microsoft, Meta, and Google scrambled to build their own artificial intelligence systems, they had no choice but to buy NVIDIA's latest H100 chips. In fact, by 2024, NVIDIA had captured over 80% of the global artificial intelligence chip market. But NVIDIA's true genius isn't just that they make the best hardware. Their real moat is the software. Because millions of developers have spent nearly 20 years writing code exclusively on NVIDIA's CUDA platform, switching to a competitor's chip like AMD or Intel is almost impossible. It would require rewriting trillions of lines of code from scratch. Just like Apple locked users into its ecosystem with the iPhone, NVIDIA locked the entire global developer community into its ecosystem with CUDA. They didn't just sell the shovels for the gold rush, they owned the entire mountain, the mining equipment, and the map. The trajectory of NVIDIA is a masterclass in long-term vision, calculated risk-taking, and software dominance. It is a journey that climbed from a roadside diner to the absolute peak of the global technology sector. NVIDIA succeeded because they chose to build the future decades before the world was ready for it. They proved that a hardware company's ultimate strength lies not in the silicon they bake, but in the software ecosystem they cultivate. As long as the world demands more computational power to build smarter artificial minds, NVIDIA's trillion-dollar computational empire shows no signs of slowing down. What do you think is NVIDIA's single greatest strength? Is it their undisputed hardware engineering, the unassailable moat of their CUDA software, or is it simply the legendary leadership of Jensen Huang? Let me know your thoughts in the comments below. If you enjoyed this deep business breakdown, make sure to hit that like button, share this video with your friends, and subscribe to the channel for more deep dives just like this one. Thanks for watching, and I will see you all in the next video.